Good afternoon. Good morning, everybody. I hope you're doing well. I hope you had rest and enjoyed yesterday's sessions. We had great panelists and even greater moderators. So thanks to all of them for this first day of the RTBfoods annual meeting, and welcome on our second day. I will start right away with few reminders. You've seen them in Kathy's email. She sent just an hour ago. We expect your contribution in the Q&A forum, all of you. I mean, not only work package coordinators, not only product champions or members of the advisory committee, but everybody is expected to go and have a look at on the Q&A forum online. I will share the link in the chat box. So you are actually expected to ask questions to others on their presentation, to answer questions that have been asked to you directly or to your group. No matter if somebody has already answered a question, you can also provide your own answer. Just write your name in blue bold. So this Q&A online forum is another way of interacting, of stimulating cross-work package and cross-product profile interactions. It is complementary to the Zoom chat box. Moderators are using the questions from both the Q&A forum and the Zoom chat box to animate, to facilitate the discussions. And this online forum will remain open after the annual meeting, so that we have the opportunity to interact, and also to have material to build the work plans for period 4 based on the interactions, on the different contributions that have been included in this online forum. So here I listed the pending contributions. So it means that people here in blue have been, or even breeders here, have been asked questions in this online Q&A forum. So I warmly invite you to go and see and find your name in blue and answer the questions that have been asked to you. Second reminder is the photo challenge. We have 146 photos viewable on the RTBfoods website. So if you go there, you will be able to see them in the 3 different categories. And we'll have 3 winners per category. So 9 winners rewarded on Thursday at tea break. And we have already 36 people who voted on the link provided on the RTBfoods website as well, and in PMU's emails. Today, we'll have 2 sessions organized as yesterday, one on work package 2 achievements and another one after tea break on work package 3 achievements. These 2 sessions, we'll have 2 presentations, one on medium throughput protocol for water assessment. It is to be noted that there won't be any time for discussion after this presentation. So I warmly invite everybody to post questions and comments in the online Q&A forum for this presentation presented by SIAT that will be presented after the work package 2 session. After tea break and after the work package 3 achievement session, we'll have a presentation on finance and budget. And we'll have time, 10 minutes for questions before the closure. Before tea break, we would like to make a group picture, so virtual group picture. So we'll ask everybody to switch on your camera, and we would like you to actually pick one of the goodies you received during the last 3 years of RTBfoods. It can be one of the aprons from last year, one notebook, stickers, caps, sunglasses that we had on the first annual meeting, tote bags and whatever, and to bring them on the picture with you so that we can see that we all belong to the RTBfoods family. At least if you don't have these goodies, you may have RTB samples on your site or whatever related to RTB. So it would be good to have this on the picture so that we have a good and funny picture, family picture for this year. At least we are not together, but we could have a nice picture. So without waiting any longer, I will start the presentation on work package 2 achievements. And then we'll have a discussion facilitated by Bruce Amaka from the advisory committee and Busi Mazia Dixon from IITA Nigeria.
Good morning, good afternoon, good evening to you all, ladies and gentlemen. Welcome to the RTB2 Scientific Achievements presentation. My name is Nwamanya Ephraim and I work at NACRI as a food scientist. And I'm presenting this on behalf of the different contributors from IITA, CRAD, CIAT, FSA, NRCRI, SIP, JHI, and INRA. For this presentation, we are going to give you an outline of this work that we have been doing. One is that we talk about the work plan for WP2 in period 3. 2, I'll be talking about the sensory characterization of quality traits, the main achievements vis-a-vis the relationship with WP1 results. Biophysical characterization of quality traits, specifically on the development of SOPs and the proof of concepts for new biochemical methods and rapid cooking tests. I will talk about the ontologies, specifically the databases that have been uploaded to BreedBase in period 3 on both sensory and biophysical data. And then finally, we're talking about the perspectives for period 4 and specifically perspectives in relation to sensory and biophysical characterizations and perspectives on ontologies. That is the summary work plan for WP2 for this period. These are different partner institutions working on sensory characterization, texture analysis, and biochemical analysis. The focus products are broad for all the RTB food crops that we are working on, and these products are at different levels of progress as far as WP2 is concerned. Specifically for the products highlighted in red, including EBA, boiled yam, and pounded yam at NRCRI, boiled yam, boiled plantain at INRA, pounded yam at Bowen, boiled sweet potato at JHI, acheke, pounded yam, and fried sweet potato at CNRA, and boiled plantain and fried plantain at Gagbap. There's still more work that needs to be done on these products. For sensory characterization, given the COVID-19 situation, most of the activities on sensory characterization were referred to or postponed to period 4. However, some of the partner institutions such as NAR Uganda, NACRI Uganda, and FSA undertook some sensory characterizations during period 3. In particular, for sensory analysis, 8 SOPs were validated and 1 is in progress. These SOPs that were validated include the ones on boiled products such as sweet potato, cassava, and yam, pasty products such as matoke, pounded yam, fufu, and eba, and the granular product acheke. In the development of these SOPs, 3 rules were followed. 1, standardization of the samples, that is the process so that the process is the same for all samples, control of the testing temperature to avoid variability, and then harmonization of the rating scale, which would be relevant during statistical analysis. For sensory profiles of the RTB food products, 5 databases or datasets are already available on the RTB platform, including matoke, boiled cassava, boiled sweet potato, and boiled yam. In addition, a tutorial is available to check the performance of the panel and organize data for statistical analysis. So for example, for the work done on matoke, 32 cultivars were used and 12 attributes scored on a scale of 0 to 10. From this, the results that were observed was that we could easily differentiate between the well-appreciated clones or genotypes from the poorly appreciated clones or genotypes. Importantly, the replicates were very close, showing that the panels were well repeatable, while the characteristics such as intense in yellow, matoke aroma, smoothness, and moldability in local cultivars well defined the appreciation by the consumers. As such, Chibuzi, for example, was selected as one of the best in terms of consumer appreciation, while Narita performed poorly. Furthermore, preliminary results on correlating sensory descriptors with instrumental measurements have been done. In this case, it was observed that instrumental measurements are good for structured products such as boiled plantain by using penetrometry or compression tests, as you can see on this other curve, where another squared value of 0.8 was obtained for sensory firmness and puncture force. But instrumental measurements would be poor for pasty products, so therefore other methods need to be developed, such as rheology, and also there is a need to understand that some of the structured products can be predicted using traits such as dry matter. On prediction of other sensory attributes, good prediction of sweetness by sugars was also seen in boiled plantain, and this shows that proofs of concept are needed to find biophysical predictors for texture, stickiness, smoothness, and moldability of some of these traits. For biophysical characterization, a number of SOPs have been developed for specific characteristics such as dry matter, free sugars, starch, amylose, PME activity, and cell wall composition. But in addition to that, a number of other SOPs are under development or in draft form, such as starch, amylose, pectin analysis, cell wall extraction for the different RTBs, beta amylase activity, and total polyphenols. On the side of the raw materials, SOPs for preparing raw materials such as boiled cassava and boiled yam are already in place. But also importantly is that there is progress on on some of these products, especially for extrusion at the different partner institutions. However, problems still occur where texturometer has not been received, for example, in NRCRI, CNRA, and SIP, and KABAP, and there is a need to help these groups to move forward. From biophysical characterization, it was also observed that actually diversity of processing ability and end product quality is usually observed among the different genotypes. And 3 examples of the results obtained do actually explain this. So these examples are texture and cooking ability of boiled yam, texture and cooking ability of boiled cassava, and the rating ability and quality traits of fufu. For the texture and cooking ability of boiled yam, 5 genotypes in 2 locations were worked with, and these were taken through rheology, color, and biochemical analysis. And it was observed that actually the cooking time depends on the variety and harvest location. There were no significant correlations between cooking time and firmness after steaming, and firmness actually depended on the cooking type, whether you were steaming or boiling. A very important result in terms of differentiating the different genotypes. Biophysical characterization also was done for rating progression in different genotypes, and based on penetrometer data, rating ability was found to be genotype dependent, and this allowed the clustering of the different genotypes that were worked with into 3 broad groups. 1, slow rating, fast rating, and intermediate rating clones. And these clones, this method therefore can be used to select the best in terms of what is required during rating and in the preparation of food. Still on biophysical characterization, relationship between texture and sensory attributes was seen in a number of traits. So for example, sensory firmness was found to be positively correlated to puncture force on penetrometry. Hard to break as a sensory trait was found to be positively correlated to hardness on boiled cassava, while easy to chew was also negatively related to chewiness as measured by the penetrometer. Based on this work, one could easily differentiate between good and poor quality traits, where good quality traits would include, for example, softness, crumbly, and slightly sweet taste, while poor quality would be defined by traits such as bitter and hard to chew in the mouth. Moving to product proofs of concept, 3 proofs of concept have already been undertaken, one on water absorption for boiled cassava roots, effect of pectin and degree of pectin methylation on cooking quality, and cell wall characterization, starch properties and enzyme activity of sweet potato genotypes. For the water absorption proof of concept, it was observed that water absorption at 30 minutes could easily predict cooking time and henceforth be used for screening cassava clones. Looking at the box plots on this curve, one can easily tell that the varieties could be ranked or differentiated between short cooking, medium cooking, and long cooking genotypes. And these are as shown as above, but importantly, the short cooking genotypes also had high water absorption, while the long cooking type of the varieties had low water absorption. So therefore, cooking ability was inversely related to cooking time, and this result is very important, especially when screening for cassava. But importantly, diversity was also observed in the different clones used, and hence, therefore, one can easily select for what is required by the consumers. On the effect of pectins and degree of pectin methylation on cooking quality of boiled cassava, it was observed that the firmness of boiled cassava increased with the level of the non-methylated pectins. This is a very important result because we understand that non-methylated pectins can easily form hydrogen bonds with other components of the root, increasing the firmness or increasing the texture or hardness properties of the root, henceforth determining whether the product will be firmer or harder than the other one. But important also in this case is the fact that a simple rapid extraction and pectin assessment procedure has been developed, and this will be used in estimating for the degree of methylation in the different clones. On sweet potato, still a number of genotypes were used to understand cooking behavior. However, from the studies, it was realized that no significant correlations occur between root composition and cooking time and firmness. We think that this is related to the fact that the samples used were inappropriate and the procedure also used was inappropriate. Therefore, more work is being done at JHI and SIP in Kenya, and another SOP is being prepared, and we hope to have better results on this in period 4. Still on cell wall characterization for cassava, yam, sweet potato, and plantain, it was observed that there are specific differences in the yield of cell wall material and pectins in the different clones. So specifically for work done at SIP within 15 genotypes, it was observed that the yield for cell wall material and pectins are differed, showing diversity in these clones and hence possibility of selection for consumer preferred clones. On the ontologies, work has been done, and since in sensory analysis, about 74 variables for food product ontologies have been uploaded so far, and this will enable the breed bases to integrate these sensory trait measurements, and then maybe the breeders will be using them in future. But in addition to that, food product property dictionaries for matoke, boiled cassava, boiled sweet potato, and boiled yam have also been produced and have been uploaded on the RTB platform and are available on the breed basis. For biophysical characterization, 2 ontologies were developed and uploaded to cassava base, including one at Nakuri with 5 variables and one at SIAT with variables. These can be accessed, as you can see from these pictures here, where the uploaded ontologies are from the 2019 C2 set GWAS at Namuronge and Serere, and in SIAT for the 9 variables for the 36 and 28 genotypes respectively. So that has been done. So looking at period 4, the perspectives for period 4 include the following. On texture analysis, there will be more work on developing and adapting while validating the SOPs for texture profile analysis. Developing new SOPs predict mealability or mealiness in the different RTBs, and also continuing collaboration among partners, especially on the subject of rheometry. For biophysical analysis, there is a need to finalize drafted and tentative SOPs for biophysical characterization of RTB crops and food crops. There's also need to collect biophysical data to expand the data sets of RTB crops and products, and also conduct a global quality assurance ring test for all the developed biophysical SOPs. For the proof of concepts, there is more work needed to develop SOPs for cooking time and water absorption, conduct product proof of concepts on the effect of polyphenols and polyphenol oxidase, and continue to work on cell wall component starch characterization and enzymatic activities. For sensor analysis, there is more work needed in terms of understanding external preference or constructing external preference maps to identify the main quality attributes. But this also will go along with finalization of SOPs for preparation and sensor evaluation of the different products. And if this is done, then possibility of performing sensor evaluation will be a matter of making sure that people do the work, and then this will be followed by tutorials and the link between sensor and textual and biophysical data using appropriate statistical processing tools. On the databases, there is a need to develop biophysical and textual databases using harmonized and approved SOPs. Develop sensory databases using harmonized and approved preparation and sensory SOPs, and also develop the ontologies. But importantly, on the ontologies is the realization that actually several partners have limited experience in formatting WP2 datasets, so therefore there's a need to support and train the partners on the process to ensure that quality data is uploaded. So already there is a strategy in place to do this, and this strategy involves the provision of training and support to RTB food partners, formatting of the data according to RTB Foods templates, and also uploading to the RTB Foods website. So that's what we have for you from WP2. Thank you very much for listening in, and we hope that you give us comments that will make this work better and better in future. Thank you very much.
Thank you, Ephraim, and thank you all Work Package 2 partners. I'm now giving the floor to Bruce Amaker and Busi Mazia Dixon for the 30-minute discussion.
Thank you, Eglantine, and thank you, Ephraim, for your really excellent presentation and significant progress from WP2. My name is Bruce Amaker. I think I know most of you. I'm at Purdue University. My area of expertise is in food science, cereals in particular, carbohydrates, and the nutrition side of things. And I want to have Busi Mazia Dixon, my co-moderator, introduce herself. Busi.
Thank you, Bruce. Colleagues, let me apologize for joining late. I think I was held up in another meeting and I did not look at the time. My name is Busi Mazia Dixon. I'm a food scientist by training, but profession, I actually combine food science and nutrition. I work for the International Institute of Tropical Agriculture, as you can see. Over to you, Bruce.
Thank you, Busi. I'm going to, because we have a rather large group in WP2, instead of going around and having each introduce him or herself, I'm going to introduce everyone. And as I had suggested that to Busi, I wasn't thinking about the difficulty in pronunciation of names, but here I go. Of course, Ephraim Manya, I'm sorry, from NACRRI in Uganda. Thierry Tron, WP2 co-leader from CRAD, stationed at CIOT in Colombia. Mark Taylor from JHI in the UK. Bolanle Otebayo from Bowen University in Nigeria. Christian Mestres, WP2 co-leader from CRAD in France. Good to see you, Christian. Michael Adesokan from IITA in Nigeria. Is it Ugo Chijioke? Sorry if I mispronounced that. NRCRI in Nigeria. Christoph Bugod, probably mispronounced your name, Christophe, WP2 co-leader from CIRAD France, Mukani Moyo from SIP in Kenya, Noel Akisoe from UAC FSA in Benin, Catherine Iba Dejeji from CNRA in Cote d'Ivoire, and Agnes Roland Sabate from INRA-E in Avignon, France. So it's good to be with all of you. And Busi and I are we have some questions from the Q&A site that have been developed over the week. And then I'll also be going to chat questions. Some of them have already come up, but Busi, we have, I think, 4 questions that we'll pose to the panel, and we'll open it up to the panel, not have every panel member answer it, but and we may pick on individuals also. So Busi, go ahead.
Thank you, Bruce. Panel members, the first question is concerning the correlation of the instrumental measurements to the results obtained by the sensory panel. Have you defined a protocol so that each partner can validate its test to ensure to have a discriminating instrumental test? For example, number of measurements to be done, type of statistical analysis to be conducted on the data. Do you envisage in period 4 to systematically test for all the partners the discriminating of the textural and rheological measurements? That's the end of the first question.
I think Christophe can reply to this question on sensory analysis, but I think there is a response or answer from him on the Q&A table. He is developing now a tutorial to interpret the data from sensorial analysis and to make the correlation between sensorial analysis and textual analysis. Is it okay, Christophe?
I think the question from Dominique is not really about relationships between instrumental measurement and sensory panel. If it's the case, okay, the answer is that we are preparing a tutorial for this, which will focus on multilinear regression and the use of calibration and validation sets. But I think the question is more directed to texture measurement specialists on how to set up reliable and discriminating instrumental methods.
Okay, so I think it's both, no?
Perhaps both.
Do you understand this?
But for the first part, we are preparing a tutorial on this.
Mm-hmm.
And concerning
on the statistical method.
I think that answers the question. For period 4, a tutorial for the group for period 4. A second question and it was, Christian, you answered many of the questions, and Christophe also on the Q&A, but I thought this would be good for the whole group to hear. Should the NIRS from WP3, I believe, or is it 4, and sensory databases be linked? And more broadly, do we need an SOP for WP2 and WP3, it is, analytical chain? So it's a question about linking the two WP2 and WP3 in a perhaps closer way, I guess.
Yes, it's a question about how to link the data and the samples between WP2 and 3. And I think Thierry Tran already replied about this. And we wanted to define a procedure to WP2 and WP3 to be sure there is a clear correspondence between the analytical data and the NIRS data. But I don't know where we are now on this, on each product profile. Perhaps Thierry can complete my reply.
Yes, good afternoon and good morning, everyone. Thierry Tran speaking. So far, in the case of boiled cassava, at least, the WP3 has developed templates to collect the NIRS data. And they included a sheet, it's an Excel file. They also included a sheet to collect the WP2 biophysical data. So we have a structure to join together the data sets from WP2 and WP3. Normally using the same identification codes for all the clones and genotypes in the data set. And then the next step is to upload those data to the breed bases, where the structure of the breed base is designed to ensure the traceability and the data and make sure that the different data sets are identified in a standardized way and harmonized way between sensory, biophysical, and NIRS. This is all based on the field trial. The first step is to define a field trial with the codes for all the genotypes in the field trials. And using those codes, we can identify in a unique way the different data sets results.
Yeah, thank you, Thierry. I think that's quite clear. Let me go to one of the chat questions, an earlier one from Michael Friedman. How have the panels that were trained earlier been affected by the delays due to the pandemic? Will you need to train new people, or are most of the trained panel members still available later this year? Really, for anybody on the panel.
Yeah, thank you very much. I'm Bolanle Otegbayo from Bowen University, Nigeria.
Hello, Bolanle.
Yes, thank you very much, Bruce. Yeah. Now, concerning that question, what we'll do is that though some of the panelists are still around, but it is very good, and I think it's compulsory for us to retrain the panelists in order to still check whether the panelists are still conversant with what they are doing and to check their repeatability. It is important. Training and retraining should be ongoing. So when we are starting the sensory evaluation, we'll retrain the panelists again. Thank you very much.
Thank you. Are there any other comments from the panel on that? This continual training of the panel members, sensory panel members.
Maybe I can comment.
Please.
In doing sensory analysis, it's normal to have some panelists becoming unavailable. So regularly, every 6 months or every year, some panelists are leaving for any personal reason, and we need to find new panelists and train them to keep the panel complete.
I am Catherine Iba from Côte d'Ivoire, Sierra.
Hi, Catherine, go ahead.
Yes. I think we need to train the panel again because some of them are gone. We cannot find them anymore because they are left the city of whatever. And then the times from the first training and now, they have forgotten many things that we need to go back and train them again.
Thank you. Any other comments from the panel? Okay, Busi, do you want to go to the next question?
Thank you. Do you plan to strengthen these studies on all crops consumed as boiled, concerning the initial dry matter or the water absorption during cooking as prediction tools of the cooking behavior. I think it's referring to the studies on water absorption and cooking time.
Mm-hmm. You're right.
Do we plan to strengthen these studies on all crops consumed as boiled?
So I had maybe lifted that out, and it's perhaps it doesn't have all the context, but you're right, Busi, that's what it's about. It's about the relationship of water absorption, right? During cooking, are they going to be, is that going to be used on all crops consumed as boiled as cooking, as a prediction tool for cooking behavior? Theory, maybe you could address that.
Yeah, we found a relatively good correlation in the case of boiled cassava, but so far we don't have results about other boiled products, boiled sweet potato, boiled yam. I feel that would be a question for the partners working on those products to decide whether it's something they want to explore. But for me, it would be very interesting to apply the method to other boiled products to see, does it work the same, or is there a different behavior from boiled cassava?
Okay, good afternoon, good morning, everybody. My name is Ugochi Joke from Nigeria, RCRI. I think we agreed in Nigeria that we'll apply the protocol that Thierry used on boiled cassava for boiled yam this period. So we intend to look at it between IITA Nigeria and NRCRI in DK. The two partners are working on boiled yam. So we want to check the effect of what Thierry did in boiled cassava will apply to boiled yam this period and see if there's anything that can come out of it. Thank you.
Yeah,
Hi, may I make a comment? Hello.
Hello, hi, Mark, go ahead.
Hi, everyone. Good afternoon or morning. Yeah, I'm unaware of water uptake being a factor in boiled potato or sweet potato, but please someone correct me if I'm wrong. Certainly for potato, I don't think so. But maybe other people know differently.
Hi, Mark. Yeah, we don't know yet because we haven't done the experiments. What we see in cassava is that the dry matter and the starch don't really have an effect on the water absorption and on the cooking quality of cassava, boiled cassava. And on the other hand, we strongly suspect, and we start to have evidence that the pectins and the cell walls are the key factors determining the cooking quality. And one of the questions is it the same in the case of other roots and tubers, or maybe in potato, sweet potato, yam, maybe the starch and the dry matter also have an important role, and the cell walls may have a lesser influence on the cooking quality. That would be the type of question we need to answer first. Is it the same for all the roots and tubers, or do we have different phenomena in different crops?
Let me go to a question on the chat from Jan Lowe. She asked, she would like more insights on what you think was wrong in the SOP used to assess the boiled sweet potato, and also the findings concerning beta amylase in sweet potato that she had thought were relevant. I see, Christophe, you had answered some of that on that. Maybe you could start, Christophe.
Yes, about sensory SOP. for me, it is okay. I think there are too many attributes. 27 is too much for a panel, but it's okay. I think this question is not for sensory SOP.
No, I think the question is about the texture analysis.
Yes.
Perhaps Mukani can reply to this question.
Yes, I can. Good morning, good afternoon, good day, everybody. So with the texture analysis protocol that we had developed in period 2, the challenge that we faced was that the sample preparation protocol was not well aligned, or it was not harmonized with with the SOP for sample preparation for cooking time and also for sensory attributes. So this is actually being worked on as we speak. We have reviewed the SOP and submitted it to the lead team in CIRAD for them to review, where we are now using an SOP which is well aligned with the SOP for cooking time and also for sensory. So I think that is where where John Low's question lies.
Thank you, Mukani.
So the results of this will be shared in period 4. So the SOP, the revised SOP for texture analysis, is currently under review.
Mm-hmm.
Can I add to that? I mean, I think the results that SIP have published have shown a very clear correlation between beta amylase activity and cooking time. So, I mean, I think that goes a long way to addressing one of the issues, and maybe that's something we need to confirm. But it seems that in contrast to what happens in cassava and potato, it's the beta amylase is the most important factor.
Thanks, Mark. Any further comments on that question? Okay, thanks. Busi, go ahead for the next question.
What are your views on how work package 1 and work package 2 can improve communication, particularly as work package 1 will be merging with work package 5? It may change dynamics and will be good to discuss with PMU what this means for our interaction. That's the question. How do we improve communication between work package 1 and work package 2, as work package 1 is going to merge with work package 5?
Perhaps it's a question to you, Busi, or to PMU.
I think it's a question for the panel, because if the people doing the work are not communicating with each other, even if the leaders are communicating, the work will not go. And so, panelists, maybe we can start by asking ourselves, we were communicating well in period 1, 2, and 3, because as we move to period 4, work package 1 and 5 will be combined. But to my knowledge, actually, I don't think there will be any issues, because the people who are in work package 1, 80% of them are the same people who we're working with in work package 5, especially for Nigeria and IITA. I could attest to that. And so since we've been communicating, planning together, doing things together, in terms of work package 1 and work package 5, to say it may affect our communication, I think maybe I don't see any issues, but colleagues can add to that.
Christophe, I don't think I will answer to the question, but I can only tell you that on Thursday, for the RTBfood annual meeting, we will have a workshop on the interactions between WP1 and WP2 on the activity associated with sensory analysis. In order to define the ideal product and the optimal threshold for the key attributes. So this workshop should allow to see more clearly afterwards what should be done between WP1 and WP2 on this aspect. I can only tell you about this.
Well, in support of what Dr. Mazia said, I don't think majority of the people that are working on WP2 are also the people working on WP1. So already I say kind of synergy and communication between them. For instance, in Nigeria, we work together. So we don't really have the problem in communicating between the two work packages. Thank you.
But maybe what needs to improve, maybe we need to get more of the co-leaders of work package 2 involved, especially when we are, I can only speak for Nigeria, when we are doing our meetings as a country and also as an institute. It will be good because then they can see the synergy between work package 1, work package 2, work package 3, and work package 4 and 5. And in the other countries, I am not sure how well things work. But as for work package 2, I think we also need more communication as a group, especially with the core leaders of the work package when it comes to the different teams in the countries.
Thanks, Brucey. I'm going to go to, there's a lot of questions in the chat, and I know we won't get to them all, but here's maybe something that would be interesting to the larger group from Hakeem. If water absorption at 30 minutes can be used to predict the cooking time of boiled cassava, does it apply to G by E varieties also? And then Hans notes, for potato, we often observe water loss during cooking. Something from the panelists, does it apply to G by E varieties also?
Thierry speaking. Yes, among the varieties in Colombia, we cultivated them in different fields. We harvested at different ages, like 8, 9, 10, 11 months. And we cultivated them, repeated the experiment over 2 years. So we had different environmental variations, and we find the correlation still holds over 2 years of experiments. However, this is valid within Colombia for Colombian varieties, which tend to have a fairly short cooking time between 20 and 30 minutes. So in other countries where cooking times seem to be more between 40 and 45 minutes, the protocol may need to be adapted to take into account the longer cooking times.
Thank you, Thierry. Busi, I guess we have time for this last. It's more of a comment, but please go ahead on question 5. I think we have, is it time to conclude? Eglantine says, so I guess we're finished. Thank you, Busi. Okay, thank you to the panelists. It was a good discussion. And back to you, Eglantine.
Thank you.
Okay, thank you to both of you for this discussion. Of course, we did not have time to address all questions. That's why we really emphasize on the importance of the Q&A forum. And we'll also have the opportunity to discuss together how to enhance the interactions between work packages during Thursday breakout sessions, as Christophe mentioned. I'm now starting presentation from CIAT on water absorption protocol. And there will be no time for discussion after this presentation, and we'll directly jump to the group picture, to the family picture.
Good afternoon, ladies and gentlemen, señoras y señores, mesdames et messieurs. Welcome to this presentation on the method for water absorption for the assessment of cooking time, part of the RTBfoods annual meeting 2021. My name is Thierry Pran. I am a food technologist at the Alliance Bioversity and CIAT at the Cassava program. I will present on behalf of several contributors, John Belalcazar, Larry Moreno, Jorge Luna, Alejandra Ospina, Christian Duarte, Andrés Escobar, Hernan Ceballos, Xiaofei Zhang, Luis Augusto Becerra, and Dominique Dufour. In this presentation, we will see that cooking time is an important criteria to assess how long it takes for boiling cassava to become soft in relation to the softness sensory attributes identified by the work package 1. We will see that dry matter cannot predict cooking time, and that on the other hand, water absorption is a repeatable method with a significant correlation with cooking time. And having developed a stable water absorption protocol, we are currently implementing it for actual breeding activities to pre-select short cooking clones. At the beginning of RTBfoods, we selected a contrasted panel of genotypes from short cooking to long cooking, or more generally, from good cooking quality to bad cooking quality. We multiplied them and started to evaluate their cooking quality. We found some clones with stable and predictable cooking times, indicated with green arrows. We have a series at the beginning here, but also in the middle, and some clones stable with long cooking times. On the other hand, we found clones with highly variable cooking times, indicated in red. The short cooking clones tended to be softer, which is a key criteria for sensory evaluation. And we found that cooking time is important for acceptability because cassava should not take too long to cook. The current land races in Colombia typically boil in 15 to 30 minutes. So we set a target for breeding of less than 30 minutes. The conventional method to evaluate cooking time is to put cassava pieces in boiling water and to prod them with a fork until they become soft and record the time of the transition from hard to soft. There are several drawbacks. The method is slow, up to 60 minutes for long cooking genotypes. It is somewhat subjective because the assessment of the softness is by the operator, and it requires individual evaluation of several pieces and then to calculate the average. So in order to meet the objective of RTBfoods to integrate evaluation of quality criteria such as cooking time in the routine evaluation of improved clones, we need to develop a faster and more objective method. First, we thought about dry matter because dry matter is made mainly of starch, 80%, and starch is a determinant of cooking quality and texture properties of many products. For boiled cassava, we quickly found that this is not the case. There was no correlation or very little correlation between dry matter and cooking time. but also between dry matter and water absorption, and between dry matter and softness, as well as other texture parameters. So dry matter and starch are not major factors determining the boiling quality of cassava, which made us consider other components, such as cell walls and pectins, but this is another story. On the other hand, we found a link with water absorption. The short cooking genotypes were related to high water absorption, and the long cooking genotypes were related to low water absorption. When putting that on a graph, we found the following correlation equation and a good correlation coefficient of R square 0.63. With this, we can start to discriminate between short cooking genotypes and high water absorption, and long cooking genotype associated with low water absorption. We decided to use water absorption at 30 minutes simply because 30 minutes gave us better correlation with cooking time. When we look at 10, 20 minutes or longer, 40, 50 minutes, we found lower correlation coefficients. What happens is that at 10 and 20 minutes, the long cooking genotypes haven't absorbed much water yet, so we cannot discriminate very well between them. And on the other hand, above 30 minutes, the short cooking genotypes start to be overcooked and start to disaggregate. So we are not actually measuring water absorption anymore, but more the disaggregation and the loss of material from the samples. To finalize the water absorption protocol, now we use 8 pieces taken from 4 to 6 different foods, mixed and boiled together. We record the initial weight before boiling and the weight after 30 minutes. And we calculate the water absorption as the change in weight between before boiling and 30 minutes, expressed as a percentage of the initial weight. We have developed a color-coded cutting map to make sure that pieces from the different foods are mixed together and boiled together. So in this example, pieces from the red squares are put together for boiling, and the same for pieces from the blue squares and pieces from the green squares. So the method is faster than the fork method. We use 30 minutes for all genotypes. It is a simple weight measurement, so there is no more subjectivity. It is stable. As we evaluate several pieces together, we get average representative sample of the genotype, and it is repeatable. When we do several applications, we have correlation coefficients around 0.9 between applications. The correlation presented above was obtained from the dataset of period 3, collected between December 2019 and February 2020, and with the dataset of period 4 from January to March 2021, we were able to confirm the stability of the correlation over 2 years and for different ages of the plants at harvest. So the method is suitable in particular to screen out long cooking genotype for which the correlations can be considered linear to the left of the graph. For short cooking genotypes, we have some of them with water absorptions up to 40 or 45% when the cooking time reaches a minimum of between 15 and 20 minutes. The next step was to show how water absorption can be useful for actual breeding activities. In 2020, we used it to select short cooking clones among a population of biofortified cassava. The initial population was F1C1 with 3,200 clones, and we selected 390 clones that were advanced to CET using 4 selection criteria: water absorption, as well as dry matter content, beta-carotenoids, and total carotenoids. On the graph, you can see the difference between the selected population and the initial F1C1 population. In period 4, we are also using water absorption to evaluate the RTBfoods progeny, which we obtain by crossing the initial collection of cooking clones to study the inheritance of cooking quality traits. For periods 4 and 5, we will finalize the standard operating procedures for water absorption to make it available for RTBfoods partners. We will expand the dataset of quality traits of boiled cassava, including water absorption and cooking time. In period 4, we are starting to conduct sensory analysis, so we will be able to investigate correlations between water absorption and sensory traits. Water absorption is still a medium throughput method. At the moment, we do between 40 and 50 genotypes per day. So we will investigate predictive correlations with NIRS in order to upgrade to high throughput phenotyping with the target of doing 100 or more than 100 genotypes per day. Working with CIRAD, we will also investigate the link with pectins by analyzing the composition of pectins and looking for explicative factors of the water absorption based on the pectins. We are also uploading the data sets to Cassava Base and starting to manage the data in Cassava Base. We are also thinking of water absorption 2.0 to record the weights of the roots directly in the boiling water, suspended in water. As the roots absorb water during boiling, their volume will increase and their density will decrease gradually. So we should be able to measure a reduction of the weight when the roots are suspended in the water. This we start to see when we compare the weight in water of short cooking genotypes. We see a strong reduction. And for long cooking genotypes, the weight will decrease as well, but to a smaller, more limited extent. The benefits of such a method would be still to predict the cooking time, but also to collect information on the density and the volume of the roots, which then we can link with the structure of the cell walls and the composition of the pectins. Practically, weighting the roots suspended in water means that we wouldn't need to remove the roots for the weighting, and we could do continuous recording of the weight and automatize the process by connecting the scale to a data logger. Finally, I want to mention the institution and people behind this work, the Alliance Biodiversity and CIAT, the Cassava program, RTB Flagship 4 and Cluster 4.2 in particular, and then the whole team who have participated and contributed with a lot of enthusiasm to the development of this method, multiplying the test, trying different conditions until we got to a final protocol. Thank you very much for your time and attention, and talk to you soon for the questions and discussion. Thank you.
Thank you, Thierry. And thanks to the CIAT team for this presentation. Everybody can go and comment, ask questions in the Q&A forum. I resent you the link through the Zoom chat box. We are now having our family picture. So I'm asking everybody to switch on your camera. You have 1 minute to switch on your camera, and I will take pictures in 1 minute. Good. If you have something funny, good, Gérard, I see that you have your badge from the last RTBfoods meeting. I have this, and I have this sticker on me. Okay, good, Denis. Who else has a goodie? Okay, Michael has the USB key. Cathy, you have the notebook as well. Switch on your camera, everybody. Okay, I see, Emmanuel, you have the sweets, the sweet box. That's good. You still have them. I also do. Okay, let me see if you have all open, switched on your camera. Didier, Alexandre, Tessie, Hernan, Laura, Brigitte, Elizabeth, Aliénor, Marie-Angélique. Okay, good. I will start the picture.
Can you see me?
Probably Bolanle. No, we can't. You're still in the shadow. Okay.
And my dog.
Your dog. Yes, we can see your dog. Good, Christophe.
But Christophe, did you have a dog in Uganda?
I'm not in Uganda.
There is Miriam babies.
Okay, I start the first picture. We have 3 pages. So let me take... Okay, smile, everybody. Second picture.
I failed to start the video camera. Please select another video camera. Why?
Okay. Okay, let me do the second picture. Good.
Dominique, what's that?
Plantain. From
Great.
Colombia. From Colombia.
Good. Okay, last one.
Can you see me?
Yes, Zinka, we can see you.
Okay.
Can you see me?
Let me look at you. No, Bolanle. Okay, yes, I can see you. I'll redo another one for Bolanle then.
Yes.
What about me?
Hola, Bolanle.
Eglantine, can you see me?
Yes, we can.
Yes, we can.
Okay, thank you, everybody. Thanks for joining the picture. It's good to see you.
Hi, Gerard.
Hello.
How are you doing?
I'm fine, Emmanuel, and you?
Yeah, I'm okay.
Yeah.
Hi, Gerard.
Good.
Hello, everyone.
Have you taken it?
There's a way you. No, there's a way.
Bon anniversaire.
Wow. That's nice.
Bye-bye.
Okay, so it's now time for tea break. So we'll meet in 10 minutes for the work package free achievement session. See you in 10 minutes.
Hello.
Good, Noel. Good.
Yes. Please go to the Q&A during the break. Fill the Q&A. There's a break now, and you will need to go to the Q&A to fill the question and answer.
Là, je voulais lui dire que nous, on n'a pas de briques ici.
Elle va mettre des photos. Églantine, tu mets la vidéo?
Ça y est, on lance ça.
Églantine.
Oui,
Bonsoir,
Noël.
Églantine.
Oui.
Bonsoir, c'est Nzoé. Boni. C'est Boni.
Ah, Bonnie.
Oui, mais elle n'a pas pu avoir d'image. Hein. Nous sommes à Boaké. Elle n'a pas pu
De
avoir
caméra.
d'image. Oui, caméra, oui.
Ok, c'est pas grave. Tu es avec qui?
Je suis avec le docteur Isis Brice. Et puis la doctorante
Ok, on mettra vos photos. On va les mettre. On va les ajouter.
Merci.
À tout à l'heure.
Églantine, tu m'entends? Églantine.
Oui, Pierre.
Tu m'entends bien parce que j'avais des problèmes de micro là.
Ok, non, je t'entends très très bien. C'est parfait.
Bon, ça marche alors. Ok.
Ok, à tout de suite.
Ouais.
welcome back. Welcome back for the Work Package 3 achievement session. I'll start the presentations from the Work Package 3 coordination team, and then we'll have a 30-minute discussion facilitated by Pierre Dardenne from the advisory committee and Hernan Ceballos, who was a cassava breeder at SIAT Colombia.
Good morning, good afternoon, and good evening, based on the zone you are watching this presentation. I want to welcome everyone once again to WP3 Scientific Achievements presentation. And my name is Emmanuel Lamon, and from IT, a co-leader of Work Package 3. I'm presenting on behalf of the team, of the Work Package 3 team. The organizational mission of WP3 in the RTB framework. As you can see on this slide, 5 researchers assume the coordination of the work package, and 8 institutes are engaged in WP3 works. This institute originated from 7 countries, and these are Uganda, Nigeria, Colombia, Peru, and Guadeloupe, Ghana, and France. What is the main mission and the role in RTBfoods framework, that is WP3? Our mission is WP3 develop high throughput phenotyping protocols that can be applied in national and international breeding programs. And our main role is in relation with WP2. We try to, in cooperation with them, during the sampling, codification, analysis, and WP4 is involved in sampling, codification, and predictions. What are our contributions to the output of RTB projects? Our contribution to the following output. The first one is screening capacity for quality traits developed, and then the second one is high throughput phenotyping or medium throughput phenotyping protocols developed for quality trait screening, and also RTB spectral databases and calibration for quality traits. In this period 3, we really affected by the COVID-19, and mainly on majority of trainings were cancelled, especially the trainings that involved the field trainings, especially, for example, that of NRCRI. We plan to be there with them to work them on the field, but we couldn't travel because of the COVID. Another effect of COVID is scheduled harvests were impossible, or if they were possible, they were very late in the year. And this particular effect caused result in delays in NIS and also in chemistry analysis by WP2. Also, some databases and arbitrages were not done, and then we plan all these delayed activities. We put it in period 4, and we hope that we are going to do that in period 4 as the COVID effect is subsiding. In period 3, under SOPs, we developed 14 SOPs, and the breakdown is NACRI 3 SOPs, IIT 3, CIRAT 5, NRCRI 2, and CIAT 1. The procedure for the SOPs, we have a team which is being headed by Karima for the editing, and then the submission by the partners, and then the reviewing is being done by the coordination team, and correction and final validation are being done by WP3 leaders. So these SOPs cover different product profile, that is different forms. We have the intact fresh roots and tubers, we have the ground fresh, we have the ground dried, and then the semi-processed products. So the MTP and HP techniques were used for for development of this SOP, and this starch grain size measurement by CCD camera, and the color oxidation by using the colorimeter. Diverse instruments were used, benchtop, portable spectrometers, hyperspectral camera, and CCD camera. Data management and ontology. We generated a lot of data from period 1 down to period 3. So what we did in period 3 is we changed the template. We developed a new template in order to meet the BTS format. We developed a template to unify the spectral databases format. All spectral databases submitted and they were validated using a template by our partners. And we have over 4,000 niche spectra uploaded in PreBase, about 1,000 spectra in cassava base, almost 3,000 spectra in sweet potato base, and about 249 spectra in yam base. What are the challenges we faced in data management ontology? The first one is we find it difficult a little bit to link spectra to the trials metadata, and also difficulty to put spectral data in VTI format. We tried, and then we were able to overcome the challenges, but we hope in period 4 we will perfect this. We will perfect this solution to these challenges. What are the next steps for data ontology? We plan that each partners to appoint a data manager. Some, they have data manager now, but we are believing that PMU will coordinate this, all the data managers to have a training and then to have a expectation that we want from them. Each data manager will manage the uploadings of all spectral data into the PreBase, so together with the WP3 coordination. Databases and calibrations during the work package 3 regarding the output 1.53, 1.54 related to RTB databases and calibration. The WP3 strategy was to develop a specific form shared with different teams. So what we did is we developed a standardized form for collection of spectra and all metadata, as we have done to develop a template, which I mentioned before. Then we scanning according to SOPs and sample codification done at team levels. So the spectral acquisition for the development of prediction models. Cassava, we have around 7,000, yam 200, and banana 377, sweet potato 609. So different forms, we have fresh intact, fresh ground, and dry flour. So the products include the meal and unmade garri, wet fufu, and both sweet potato. The spectral databases for good and poor genotypes, we collected some data bases for that, and also data sets dedicated to instrument standardization. Databases calibration continue. The proof of concept and calibrations. What are those things that we achieve under that? 20 calibration developed and improved. The main constituents calibrated refer to major traits such as the dry matter, proteins, starch, sugars, and micronutrients. For example, carotenoids. The physical and functional properties we explored include color, texture, and functional parameters such as swelling power, dispersibility, and solubility. The calibration performances are unequal, yes, in terms of the specificity and selectivity and accuracy. And we propose that it needs a major improvement, which we are going to do in period 4. The hyperspectral imaging potential was tested for characterization of boiled yam, like cooking degree of time, and then we have POCs that were done on good and poor genotype discrimination. which mainly concerns cassava. Yeah. The good poor philosophy, we want to just present 2 or 3 slides on that. We plan on in WP3 to look at a way where we can be able to solve some traits that are not easily predictable, and in order to help the breeders to have a good instrument to screen their breeding materials as quick as possible. So the good and poor approach is a shortcut between WP1 and WP3. That is, the data generated from WP1 can be used to link with the spectra in order to be able to classify, yes, these materials based on the responses, and it can be a binary responses, so that we can be able to develop needs and then use it to classify these the materials. Yeah, is capture by physical drivers or preferences is necessary, but they are complex. We all know that. And so that good and pure HPP method can complement classical approach. So, yeah, what is the methodology of the good and poor in comparison with the compositional traits? The prediction of functional traits or overall quality by NACE, it relies on complex mechanisms involving many compounds, potentially linked by nonlinear relationship, threshold or composition effect. Therefore, classical prediction such as PLS is a little bit difficult. So it seems unsuitable for some functional traits. And so also, it often rely on tedious and less reliable reference method, so leading to small and noisy data sets, e.g. the cassava cooking time or yam pandability, for instance. They are quite hard to quantify and take time to do. Good and poor prediction belong to classification problem rather than regression. So most of the time, classes are unbalanced. For instance, 100 slow cooking genotype, 40 fast cooking. This implicitly led to unbalanced weight for each class. So for all these reasons, we choose to bring some innovative tools to address such challenges. Convolutional neutral network is one of the solutions we brought, and also the feature augmentations in order for us to generate, not to generate more noise, and then the feature and data augmentation as well. So these are just the proposed solutions, improvements we brought into the good poor methodology using deep learning machine. If we need more details, and then we can refer to the webinar that we deliver, Dennis Connect delivered some times ago. You can refer to that, so to get more information on the good and bad methodology. So good poor databases, we try to view the database, good poor databases. For some traits, as been mentioned, that some traits were being developed as classification for yam modability, and then for cooking time, and then the yam good or poor genotypes. So 81 samples for yam modability. The trait is modability after mechanical pounding, which the response is yes or no. The second data set is to classify the fast and slow cooking root of cassava. And then the third data set is for MITA, which is provided 200 yam samples with a binary classification of genotypes relying on suitability for pounded yam. So the preliminary results is very encouraging. We use open source software, and despite the small size of the available data set, so first result demonstrate a good accuracy of the method here. And indeed, accuracy was always higher than 80%. So as we can see, 0.8 for yam modability, 0.83 for yam good and poor, 0.860 for cooking time. So the preliminary results open up a very promising prospect for breeding program. Should this result be confirmed, the objective will be that we need to calibrate a model by product profile based on the rawest possible material, e.g. crude fresh yam and the fresh fruit, cassava and sweet potato. During this period, we have 3 publications under our package 3. One review paper on this application in cassava yam, which is published in IGFT, it's under the special issue, and one paper on prediction performances of near infrared for quality trait of fresh yam. And then the other one is on predicting quality texture and chemical content of yam tuber using near infrared spectroscopy. This paper has been accepted and is going to be getting DOI very soon. So the highlight from the papers, different high throughput procedures for characterization of cassava and yam germplasm, they were identified. And we can also see that deep learning classification algorithm allow to produce a rapid prediction of pounded yam composition and texture. And the NIS could be used also to produce a rapid prediction of most of quality traits. The calibration models performance statistics showed a good R-square prediction for dry matter, starch, protein content of yam samples for blended method. Successful analysis of fresh tuber crops with NIS could lead to elimination of the tedious sampling preparation process. So that's our ultimate in this project, that we want to make sure that breeder can have a models that can work on the fresh materials as much as they can. Yes, in conclusion, all the teams run NIS as routine. That is what we observe, that all partners, they run NIS as a routine. They use different spectrometer, although the spectrometer used are different. Some are used bent top, some are used handheld. So for all raw root and tubers, we've worked on all raw root and tubers in different forms. And also the feasibility of NIS for processed root and tubers were also explored, that is especially intermediate product, gari, fufu, and matoke. 14 SOPs developed and validated, and also 20 calibration and the proof of concepts were developed as well. Four MTP techniques investigated, which include MRS, colorimetry, image processing, and hyperspectral imaging. Poor and good genotype approach were validated. 3 articles of main results published. What about our perspective for period 4? The first one is we want to consolidate the developed calibrations we have in period 2 and 3, and then we need to develop more models to qualify genotype as good and poor, and also to harmonize the SOPs, especially the SOPs on intertruth using portable spectrometer. So we still want to work on HSI more, image processing, and the mid-infrared spectroscopy for specific properties. We want to ensure that genotype from WP4 analyzing priority and reinforce coordination with the WP2 and also WP4. Want to just mention some things on perspective for good and poor, because we see that's a good approach. So we want to dwell more, give more time to it, this in period 4, to be able to perfect and extend it to all other product profiles. So the first thing we will do there is to evaluate the robustness of the predictions model, and then also to tackle other to be products based on historical database or new trial. That is, we may use historical data sets or we use new trials. But for those that we have worked on before in period 3, we want to extend to new trials in order to increase the robustness of the predictions models. Yes, apply the same technology to study other 1D signals, that is to extend it to other parameters, and then to improve the interoperability with the VAE and the GAN. Improving performances using model sampling like e.g. stacking. So these are just the perspective for good or poor POC, which we plan for. We want to acknowledge all the institutes that are working on the work package 3. They are the following: NRCRI team, IITA team, NACRI team, CIAT teams, ZIP team, INRAD team, NAR team, CIRAT team, and all partners from the work package 2, work package 4, and work package 5. We want to acknowledge PMU team for their supports, especially in helping us to organize the virtual meetings from time to time during the period under reporting. The advisory committee, also, we need to acknowledge you for your series of advice you are giving unto us, yes, in our work package 3. And finally, we thank our sponsor, the Melinda and Bill Gates Foundation, for their financial support. Thank you.
Thank you, Work Package 4. Thank you, Emmanuel, for volunteering to be the speaker. I'm now giving the floor to Pierre Dardenne, a member of the advisory committee, and Hernan Ceballos for the discussion.
Could you hear me?
Yes, clearly.
Okay, good. Good afternoon, everybody. So I think you know me, and I am in the board to advise the project, and with Hernan today. I will give you the word in a few minutes. So Emmanuel, thank you for your presentation, and it was a good summary, but I think you are a little bit too optimistic in my point of view, and you spoke a lot about what is the organization, the SOAP, but not enough about the result, I think. And I would like to start directly with deep learning. And you said validation about deep learning, and I think it's probably a good hope to get something from these techniques, but need to be validated. And that's good, I think, for all. Oh, okay, sorry. You can see me also now. So what I said. I said that in many places in the reports, there is mentioned validation or validated. And I think you don't have enough good feeling about what is validation. What validation is not taking 30% of the samples in the data set and make the calibration with the 70% and predict. It's not real validation. A validation is a new year, okay, of crops, of harvest. And then you validate your model. And then you prove that it works. So that's what we have to see for the next 2 years. That's real validation and not internal validation. Otherwise, you will have big surprise on the result in the future. Okay. So the first remark, I go to questions. Yes, just also from WP2 and WP3, I noticed there is no yet databases between spectra and sensory analysis. So that's something which is missing. And perhaps you have to discuss that later in the for the program for the next year. But it's pity we don't have yet all this information, because that's probably a chance to skip all these textural or cooking to get the good breeds and the good varieties in one shot and in fast way. Yes, a little bit more detail before I give the word to Hernan for his first question. But in the report, I saw two lists of data sets. There is a list with calibration. We suppose that you consider the first list is usable calibration, and the second list is for development. You have to answer that, because there is at least, as Manuel said, there is 20 calibration in one list and 26 database in the other list, but also with wet chemistry. And this morning I opened the data set from CIAT about cooking time. There is 1,000 spectra on that, and cooking time and calibration, it's completely null. So it means that cooking time, it will be very difficult to predict. And we have to think about if we have to go on that, these kind of threats for the future. So if someone can explain why we have these two lists and what has to be done to go from one list to the other. Who can answer that?
Yes, if I can. You hear me?
Yeah.
Okay, thank you. Thank you, Pierre, for your remark and questions. Thank you, Emmanuel, for the presentation. So we do have two set of data due to PMU demand. So it's the same, in fact. It's spectral database and calibration, because we decided in WP3 to work. It's easier for us to work with the one template with spectra and laboratory value in the same template. But in the point of view of PMU, we were asked for doing two separate set. So one with only spectra and one with calibration. But calibration, as you know, Pierre, is only performances of the calibration you can put. So I wanted to put in the same template. We wanted to put in the same template spectra and lab value. That's why. Regarding your question about validation. Sorry. So regarding about your question about validation, I'm fully agree with you. We say just validation because we are still on the process of developing calibration, and that's why we said in conclusion that we have to consolidate our calibration. So that means we need to test robustness, and we need to test on independent set on New Year, like we have done in CIAT for carotenoid. We have done that. We started with internal validation because you know, as me, that sometimes it's better than doing only cross validations. So it's not the right thing to do, but when you are doing under process of development of calibration, it's better to do an external validation anyway, even if it's the same sample coming from the same year, for example.
For NIR, but
yes,
I'm okay.
But I fully agree with you. And Hans as the same question in the chat. We need to be aware about robustness of our database. So we need to include variability, year variability, geographic variability, everything. So we know that.
Yeah, but that's what I would like to have. That's because the PMU, they like list. That's a list of usable calibration. List of calibration that people use on their lab.
It's under development, but the aim of this is to be used at the end, yes.
I like to jump in so that we have possibilities for touching different questions. I'll introduce myself. I am Hernán Ceballos. I am a cassava breeder and a living proof that breeders can work together with food technologists in a very productive way. I'll move to another question that was raised in the forum, and this is the wisdom or the usefulness of work on processed foods or prepared samples rather than raw samples. And I like to ask Emmanuel Alamu to elucidate a little bit on that.
Yeah, we thank the moderators. Thank you very much for your comments. They are valuable to us and to help us to improve. Yeah, actually, I saw the question and then I responded, to you on that question. Actually, our ultimate aim is to work on the raw materials, to link it up, to be able to predict the product. But we need some information on the product as well, especially intermediate products like Gari to Eba. Eba is the final, Gari is the intermediate. So Gari is also consumed in another form. So this is a process. It's a process product. So I use as an example like fufu as well. We have fufu mash before you process it to become real fufu finally. So there are a lot of information we can get from this intermediate and the final product that can help us to link the product to the raw material. Actually, our aim is to predict on the raw material in order to select for either good products or bad products. Thank you.
Thank you, Emmanuel. I think that Pierre has another question.
Yes, that's about the color measurements. I imagine a chronometer is quite fast. So I was wondering why we need an IR or the visible part of the spectrum of an IR instruments to predict color, which is measured fast in the lab. Emmanuel.
Okay, thank you very much for that good question as well. What we taught in our thought in that line to develop calibration for color is that we have the sample, we collect spectral data. It's from the same spectral data. If we have calibration, then we can get results. So that one we eliminate even using chromometer to determine the color, which is it's cost effective and it's very efficient if you can have calibration for color. We collect spectra, single spectra, then we can get the information easily. So that's line of our thought that the sample that's been brought to the lab, so we work on the same sample to get the color measurement. Not that's the big yes. So
you
that
could
is
save time with.
Yes,
you could save time.
Yeah. Yes, yeah.
But you have 3 parameters working well, and B doesn't work well, and it's not a problem for you.
Yeah, as you have mentioned that robustness needs to be checked. We use the word validation, just to see that the calibration can be advanced to the next step. So that is internal validation to check. Then the next season we can check whether calibration can still work better.
R square, it's 0.17. I don't know if we
we are going to look at it. And then you remember you sent a mail to me to check to use another mathematical treatment, which we are going to try on it and see.
We went for 88 to 91. It's not the same level.
Yeah, 88 to 91. Yeah. So if you use another treatment, maybe we get a better one, an improvement on that.
And
but we hope to improve.
A suggestion of an idiot about color measurements. If you calibrate in RGB scale, it's not working.
Yeah, we have the data for that.
So,
but why we use LAB value is for the easy interpretation.
When you have RGB, you can go back to LEB.
Yeah. So we have data for that. Yes, we can check that whether it's going to work. But we believe that
perhaps stupid question, but
we believe that AGB is directly proportional to the LAB values because it's just the angle they measure is quite different, but they are still going to give the same interpretation of the color of the sample.
Okay, thank you.
Yeah.
And Hernan? Hernan?
Another question that was raised in different ways is the wisdom of having the good and bad classification only. It has been clear that it facilitates and enhances the prediction of needs, but there might be two limited options. I mentioned, for instance, in our work in biofortified cassava, we ended up having no clones that had good cooking quality and low cyanogenic potential. So I understand that the good and bad facilitates the predictions by NIRS, but it might end up producing very limited information that breeders can use. So this is more or less also related to a question that Hans has raised. So I don't know if Fabrice can answer these concerns.
Yes, thank you, Hernan. Maybe with the help of Denise, but in fact, we can see that this approach that was advised by the advisory committee last year is a way to overtake the non-linearity we observe for some parameters. And we base our first approach on breeder's knowledge. So it could be seen as the first sort of the sample, not a final sort, but it can be a good opportunity to eliminate a part of the genotype that we know that they are not good. So it's based on breeders' knowledge. So they give us varieties, genotypes. They know they are good, and genotypes they know they are not good for one reason, for example, cooking time or pondability. And we try to do this approach just to eliminate this one. Then after we can imagine that we can go deeper for another traits that is not known by the breeder like this. When you look at the genotype, of course, if it was the case, no need of RTBfoods. So maybe we can see bad and poor as a first step for a kind of preliminary sorting of the sample based on the breeder's knowledge.
Okay, thank you. From a breeder's point of view, I emphasize that I like to have at least 3 options available for selection purposes.
I understand.
Pierre?
Okay. Come back a little bit to NIR. And I saw in the list of instruments, there is in the group 2 SIO from computer physics, this very small spectrometer. Is there already databases on that? I'm very interested to see.
No, really in RTBfoods, but I receive data from IITE in Nigeria from I guess it's from NetGen, and on fresh cassava and dry matter. And what was interesting, it was from Gabi. And what was interesting that is there is also the same data obtained with quality spec. So I started to check the data, and for dry matter on raw material and so fresh cassava, SCIO gives similar results to quality specs. So we can imagine that for for sample traits like dry matter or maybe starch, we can use this kind of instrument.
I don't know the business exactly on that crops, but tools at $1,000 or euros would be very efficient in the fields.
Of course, I
so
agree.
That's something we have perhaps to go a little bit further, because we speak about hyperspectral camera at 100,000, and we have device of 1,000. We don't use them. So that's perhaps for the period 4. Huh?
Yeah. If I'm allowed to add to that.
Okay. Just in the same.
Yes, please, Emmanuel. Please, Emmanuel.
Yeah.
Yeah. Actually, the next gen team, they have done a good work on, using cell at least for dry matter and starch, and that was the data being sent to Fabrics. So we are planning together next gen RTBfoods, work internally now to work together. We will still look the possibility, at least if we can work for dry matter and starch.
This database is available, or is something you have to ask for, or what? Or you
No, I think it's available with them, so it's accessible, I believe.
And you have the date of the recording with?
Yes, I think
yes.
Everything is fine.
Because,
yeah.
Because it's the first things to validate. That's to validate by date.
Yeah.
And then you have more independent validation.
Yeah.
Okay. So that's if I can work.
Yes, for the moment, it's 100 sample.
Okay.
Yeah.
100.
100. Yes.
Okay, that's a little bit short, but anyway.
Yes.
Okay.
No, maybe the 100 sent to you, Fabrice, is maybe the one that is related with the ASD. That is because they want to compare the ASD and the CO. That's
probably,
why they send the two.
Probably.
Maybe they still have more because they have started working on it for the past 2 years. I learned so. So they have a big database for that on the next gen. So but we can have access to that to work together.
Yeah, okay.
So, yeah.
Good. We will speak later about that.
Okay.
We will see Friday what we can do.
Yes, Pierre. Just one word, Pierre, if you agree. Yes, of course, we can imagine to use SEO, but we know that for some parameter and especially for spatial distribution in routes, we will need hyperspectral imaging. So to use SEO is one of the objective, of course, to go to the field. But we will need also hyperspectral imaging, and we do have some results just last week from Karima, promising results. We are using hyperspectral imaging.
That's just my next question. That's about hyperspectral camera, because Karima had nice picture showing the cooking and the dry matter. But I think Hans used this intensively, and we need to go further to have figures to characterize this process. And so that's, I don't know how to do that, but just looking at the picture is not enough to have a ranking of the varieties. So that's, you need more work on the result of the image.
No, that's what maybe Karima, you can say a word, but that's what we are doing right now with Karima and Christian. We work on calibration from the imaging, from the images.
Hernan, you have another question?
Yes, just to move to more on operational issues. Lara Forsyth asked if it would be possible to for some of the team to explain how work packages 1 and 3 can improve communication. I don't know who in the panel can answer this question.
I can, if you want. Okay. I can. I don't know.
Okay, go ahead, Fabrice.
Please. Yes, I've seen the question from Roy. I didn't answer yet, but it's not only between WP1 and 3. It should be with WP2, because we need to agree of, especially if we go ahead in good and poor, we need to agree about something which is not really real traits, some things it's from sensory, from perception. So we need to discuss with WP2 and 1 to decide exactly what could be the perimeter of good and what could be the perimeter of poor genotype. And regarding the traits, it should be also a discussion together to decide if we can go ahead with the traits we are doing now, or we need to focus on 2 or 3 traits for the next period. So it's important. It's a good question. Huh?
Certainly, it will be important to facilitate the communication between the different work packages. Pierre, you have another question?
Perhaps just perhaps a remark, because in the list of the databases, there is a database about the measurement of same samples on 8 instruments made in Montpellier, I think. Karima and Denis perhaps can speak about. So it means that do you think about standardization for instruments?
Yes, this is it. So we just gather the maximum spectrometer as possible with different dry products. There was cassava, yam, but also other products coming from
powder.
Yes, always powder, because we needed some stable samples. It was really not possible to work on fresh if you want really to keep the spectral signature as constant as possible. And the idea was just to build this database in order to start study on interoperability and standardization, yes.
But do you think it will work? Because each center or each laboratory where there is an instrument, they have their own calibration and their own preparation and their own wet chemistry. Because if you start standardization would be good, but if you don't standardize the wet chemistry first, how to control, how to validate?
Yes. Now here it's not, the idea is not to give a solution right away. The idea is to start some methodological development which may improve standardization in the future. It's not, the idea is not to give solution right now. The idea is to study some intelligence, artificial intelligence algorithm, and how they can also help to standardize samples not taken on different instruments, different sample on different instruments. So trying to extract the spectral signature of the product out of the interference with the machine. And for this, we have tools from, they call it generative adversarial network. You know, this is for fake image in the news, and so you can build fake image and so on. So the idea is to train this network.
That's interesting, yeah. But it's perhaps not the first effort to do, but that's surely a good research team.
Yes, it was at no cost for RTBfoods, because we get the money from another grants. Okay. And we just wanted to make RTBfood profit of this as well, but it was at no cost for it.
Oh, okay, thank you. One more, Hernando.
Let me, can I say one word to this point?
Yes,
this is Thomas. I have done this standardization across SIP platforms many years, and you can only do that with exactly the same sample, and you need a dried material for that. I think it's very difficult to have that with fresh material, if I understand that correct.
Yeah.
This will be impossible task.
We can do fresh if the instruments are
in the same
table.
Lab. Yeah, exactly. But you can do this across labs in different countries.
Just a word on this, but if it's the same manufacturer, for example, in Uganda and in SIAT, I try to use the calibration from SIAT to the sample done in Uganda, and for dry matter, the results were good. Eh?
Yeah, if it's the same brand, there's no problem nowadays. That's okay. Okay. You have a question, Hernando?
Yes, Thierry Tran mentioned in the forum that a big task for period 4 and 5 will be for partners to format their data sets, sensory, biophysical, news, and upload them to breed bases. work packages 2 and 3 will need a strategy to support this process. Has the team envisioned how to do it?
Yes. Oh, can I respond?
Yeah, sure.
Please go
Okay.
ahead.
Yeah, I think I saw the question and I put 2 or 3 lines in response to Thierry's question. It's a big task, really, because the key step is to develop a common template and in BTI format that can collect the information that could be able to be uploaded into the brick base. We took a first step in period 3. We developed a template according to BTI format, but we can only put biophysical traits, which we use for reference values. So that one is there, but we can borrow from there to develop more template for sensory as well as the textural qualities. Thank you.
A follow-up, Emmanuel, you mentioned in your presentation that you face some problems uploading spectra in BTI platform. Can you explain a little bit if you have solved the problems or they are still there?
Yes, I mentioned it just to mention to us the problem with the challenge that we faced. We tried to resolve it after several months of training, thanks to Karima and the member of WP2, WP3. We have series of meetings with BTI. So we succeeded in having a template, but to extend it to other sensory and textural, that is what Thierry mentioned, that we need to come together again to have a good template for that, because they have different ontologies. Thank you.
Okay, I got in. May I say one more word?
Yes, sure, please.
Okay, I would like just to finish by this. Looking at all the results, too many results, we can do on fresh material, whatever it's intact, ground or grated. We can do dry matter. Then the constituent, the major constituents, starch, protein, ash, sugar, and the total fiber. But it becomes difficult for lower concentration, like the different sugar, for instance, fructose, glucose, must be done dry. So, and looking at the textural parameter, RVA or cooking time, softness, and others, correlation are very, very poor indeed. And I wonder if we have to go in this direction. And I hope we can make a gap to the sensory data directly, because all these structural parameter doesn't seem to work well with NIR. And I have to say, we faced that 30 years ago, a little bit the same, when we tried to express the baking quality on our wheat. And baking quality is based on the structure of protein. And NIR see very well the nitrogen, but not the structure of the protein. And then we never succeed to predict well the baking quality by NIR. NIR see the quantity, but not the quality of the molecule or the structure of the molecule. And then I'm afraid that we could fail with many of these threats and make a big effort for nothing. And perhaps we have to go to other high throughput system or intermediate or medium throughput. But I will not insist too much on these parameters on NIRS, because when NIR can't see something, there is nothing to do. That's my end. Thank you.
Completely agree.
Thank you for the panelists and the audience for the questions. It was a great session. Thank you.
Thank you to you. Thank you very much.
Thank you. Thank you, everyone.
Thanks, Hernan. Thanks, Pierre, and all panelists. So we see that this session raised a lot of questions. I warmly recommend you to go on the online forum to keep interacting on these topics. I am now starting the last presentation for today on finance and budget, and we'll have only 5 minutes, I guess, for quick answers, quick questions and comments after the presentation.
Hello, everybody. Anne-Laure and I are happy to meet you again to present the RTBfoods financial aspects for the third period indeed. To start, we would like to thank you and your teams for the high quality of your financial reports. Despite the constraints imposed by lockdown and generalized remote working, the financial statements are very clear, detailed, and informative. Thank you also for your helpful clarification when requested. Due to the commitment of each partner, the financial report consolidated was submitted on time, March 15, to the Foundation. The Foundation congratulated us of all for the work accomplished. We are now waiting for the bank transfer from the Foundation to make the first advance payment. Following the analysis of the reports and your discussions, here are the main activities slowed down by the COVID pandemic. First, the project has experienced a delay in planting and harvesting, and some phenotyping activities were either delayed or cancelled. Concerning survey activities, due to mobility constraints, the finalization of field activities and in particular the rural surveys on preferences, the process evaluation and consumer testing activities had to be cancelled or postponed. Regarding the scientist trainings or exchanges, the inability to travel has led to cancellations or postponements of scheduled training. Regarding the laboratories activities, due to the limitation in the number of employees working on site in the lab and fewer working hours, the operations were slow and sometimes postponed to the next period. As a result, in financial terms, most of travel and other direct cost expenses have been postponed over the next periods. The other direct cost categories, including consumables and laboratory maintenance costs, decreased more significantly than the travel category. The reason is that the annual meeting was held in February 2020 in Uganda before COVID pandemic. Regarding personnel cost, the researchers involved on the project have massively promoted the first results on the project. That is why this item remained stable over this period. Let's have a look at the figure more in detail. We will sum up at the end of the third financial period achievement. Spending statements reported for the 3 periods cumulated represent 61% of the total grant allocated to the project. This rate is on track at contract midterm and in spite of several months of lockdown during the relevant period. Herewith, we can see now the percentage of budget execution per partner. The red line represents the percentage of budget achievement at this stage. Above this line, organizations that spend less than 61% of their total budget, as INRA, NRCRI or GHI. Below, the organization having spent more, like CNRA, YTTI. For biodiversity, this rate of 100% shows that all their activities were concentrated on the first 3 periods. But a budget transfer between CIRAD and biodiversity is being contracted to pursue ontology activities. Please keep in mind that budget should be totally spent and justified at the end of the project in order to obtain the total grant. That means that all partners which are beyond expenses on their budget must think about reallocating their spending as needed. Here you can see the detail of expenses incurred for budget items without overheads compared to the total revised budget. The total revised budget includes reallocation of expenditures between budget items during the project and validated by the PMU. We reach at the end of the third period 58% on personnel cost budget, 64% on travel cost budget, 38% on the consultant budget, 95% on equipment items. Most equipment have been purchased. A focus will be presented in the next slide. 52% spent on other direct cost budget. As seen in slide 3, lockdown due to the COVID explains the delay of the consumption of consumables and maintenance cost of laboratories. There remains a significant budget balance. The last item, 63% spent on the sub-awards item. On this slide, you can see all the equipment funded by the project since the beginning of the contract. All equipment except a texturometer has been purchased. During this period, were purchased by CERAD a high-intensity contact probe, a flow analyzer, a transportable hyperspectral camera, by IITA, a hyperspectral camera 2, and by Carbat, a chromometer, a texturometer. There remains a balance of $83,000 compared to the initial budget, but has been reallocated across other cost categories. We can explain this amount by additional external fundings granted to contribute to equipment purchase or by budget reallocation to other activities validated by the PMU. This slide shows now the same data as the previous one, but distributed by work package. As you can see, work package 1 and work package 2 record the highest level of expenditure over this period, which is normal since these activities start the project. The other activities started later and are concentrated at the end of the project. We can say that we are on track on the project phasing. Now we are going to focus on the result of the third financial restitution period. As you can see on the slide here, we reach 71% of execution of the forecast budget for period 3. We will see on the next slide the detail by item. On the third period compared with budget projection declared by each partners, we reach 94% of the personnel cost for recasted budget. As seen previously, despite the COVID pandemic, teams remained involved, particularly in promoting the project's results. 63% used on the forecast travels budget. This rate is quite high despite mobility constraints. Indeed, partners spend part of their budget to attend the annual general meeting in Kampala. 66% of capital equipment has been spent. CNRA texturometer has been postponed to the fourth period, and CIRAD has funded on its own contribution a part of a transportable hyperspectral camera. 43% has been spent on other direct costs. The cost of analysis and reagents have been significantly reduced during this period due to lockdown. Expenses related to the laboratory cost and maintenance were greatly reduced. The remaining budget has been postponed on the next periods. For the two other items, consultants and sub-awards, the budget for requested has been overspent, but that represents minor amounts. On this slide, we can see actual expenses declared on the 3 first periods and forecast budgets for the 4th and 5th periods. These forecasts have been updated and declared by each partner at the end of the 3rd period. Let's focus on 2021, based on the largest expenditure items. Concerning personnel costs, the remaining budget to be justified for the period 4 is around $900,000, a little higher than the other periods. CIRAD's budget partly explains this increase. After validation by the Foundation, we have planned to recruit 2 researchers for period 4, 1 specialist in ontology and 1 in data management. Concerning other direct costs, around $450,000 must be justified on period 4. That seems quite high compared with actual expenses already spent. That means that all partners which are behind on their budgets must think about reallocating their spendings if necessary. For the cash flow, the Foundation force payment is expected in May. The amounts per partner will be calculated as previously taking into account your cash balance and the activity forecasted for the 4th period. You can see on this slide amounts calculated for each partner. To conclude this presentation, the Foundation Gates suggests an extension to January 31st, 2023, without additional funding. As you can see on this slide, at the top of this graph, the contractual deadlines for the end of the project. Below, deadlines proposals that we would like to suggest to the Foundation on the last reporting deadlines of the project. If the extension is implemented, an amendment for each sub-agreement will be proposed. We will soon keep you informed about the decision. We remain at your disposal for any question. Feel free to contact us. We will be pleased to answer. We will be happy to help if any question come up. Hope to see you at the next RTBfood annual meeting. Thank you. All the best. Delphine and Laure.
Well, thank you. Thank you, Delphine. Thank you, Anne-Laure. We do not have time for questions or comments on this presentation. So I propose that you directly contact the persons here at the screen. So Dominique, Delphine, Anne-Laure, of course, and Cathy and Claire if you have questions regarding this presentation. Plus Delphine and Anne-Laure are unfortunately not available online today to answer your questions, but they remain at your disposal by email. So to conclude today, I directly share the agenda for tomorrow. So tomorrow we'll have two presentations, two sessions on data management and ontology first, then on communication achievements with two presentations from Cathy and Pascal on the website networks, and another one on from Claire on the International Journal of Food Science and Technology special issue on RTBs. Then after tea break, we'll have a panel dedicated to product profiles. As a reminder, the presentations on product profile achievements won't be broadcast on Zoom. So you are warmly expected to go and see these 12 presentations on the RTBfoods website before tomorrow, so that you'll be in capacity to ask questions in the Q&A forum first, and in the Zoom chat box secondly, for moderators Hans Verdun and Christian Mess to be able to facilitate the discussion. During this product profile panel, you'll also have a presentation from Hans van Doorn on the concept of product profile at HZPC, sorry, Netherlands. And that's it. So thanks everybody for joining today's sessions, and have a nice evening, and do not forget to go and view the presentations for tomorrow. Have a nice evening. Goodbye.
Thank you. Thank you.
Thank you,
Bye-bye.
Fabrice.
Vote for the photo challenge. Go to the photo challenge.
Bye-bye. Goodbye.
Bye-bye. Thank you.
Bye,
Thank you
Emmanuel.
very much. Bye-bye.
Thank you very much.
Take care.
Bye-bye.
Bye, Catherine.
Bye-bye.
Bye, everyone.
Bye,
Bye-bye,
Boulanlé.
everyone. Bye-bye. See you tomorrow.
See you. Bye, Thomas.
Bye. Night.
Bye-bye, Bola.
Bye-bye, everyone.
Bye. Good night.
Bye, Gérard. Take care.
Thank you very much, Eglantine.